Hello everybody. In this video, I'm going to walk you through some examples and talk you through the formulas for the volume of pyramids and cones, all right? So we're going to go ahead and jump right into it here, okay? So for any pyramid, the volume of that pyramid is 1/3 times the area of the base shape times the height of the pyramid, okay? If you'll notice, this part BH, remember, is the volume of a prism. Okay, and then you're literally just doing 1/3 of that. Okay, or if you multiply these two things together, whatever you get, dividing it by 3. Okay, this is one of those things where, like, the reason why this formula is the way that it is kind of complex. I'm going to show you in class like a physical version of it. But the actual like mathematical proof for it is kind of goes beyond the scope of this geometry class. But if you're curious as to why this formula works the way it does, send me a message and I'm happy to show you. Okay, the most important thing about this formula is that we're dealing with the actual height of the pyramid, not the slant height. So if you remember from the surface area video, we were dealing with the slant height, which is the height of the triangles that like make up the lateral area, right? That make up the most of the faces of the pyramid. Okay, this is not that. Okay, for height, we're actually talking about the vertical height of I'm throwing things on the floor, the actual vertical height of the pyramid. Okay, so this is going to work, right? This formula works no matter what the area of the base shape is. It doesn't really matter. So let's go ahead and do this first example here. Okay, so I want to find the surface area of this rectangular pyramid right here. Okay, so I know I need the area of the base shape, and I also know I need the height of the pyramid. Okay, well, the height of the pyramid they give me, it's 6. Okay, and this is a rectangle, so I know the area of the base shape is the area of a rectangle, which is BH, right? So that would be 4 times 10 in this case, which is 40. Okay, so my volume then is 1/3 times 40 times 6. Okay, so what I'm going to do actually is do 40 times 6 first. So I have 1/3 times 40 times 6 is 240. And then this number, 240, I'm going to divide by 3. That's what the 1/3 is. So 240 divided by 3 is 80. Right? And then the last thing I need is my units. So since the unit in the problem was centimeters, the unit for my volume is centimeters cubed. Right? And that's it. That's all you have to do. So volume has a lot less components typically than surface area does. Okay. All right, let's go ahead and do one more example with pyramid. Let's do a backwards example. Okay. So I've told you we're dealing with a square pyramid. I told you that each side of the base shape is 8 feet, and I told you the volume is 360 feet cubed. Okay, so I'm still using this formula. Volume is 1/3 the area of the base shape times the height. Now, I don't know the height, but I do know the volume, and I can figure out the area of the base shape. So my volume is 360. They tell us that. Okay, they also tell us that each side of my square is 8. Okay, so my base shape is a square. So remember, the area of a square is just the side length times itself. So the area of my base shape here would be 8 squared, which is 64. Okay, so now that I know volume and capital B, the area of my base shape, I'm going to plug that information into my formula up here and then work backwards to solve for what I'm missing. So volume is 360, so I have 360 equals 1/3 times 64 times the height. Now, once you get to this point, my advice would be to multiply both sides by 3. just so that you don't have to deal with this fraction anymore, because that's going to cancel out the 1/3. Okay, so 360 times 3 is 1080. Okay, and then that equals 64 times h, and then I'm going to divide both sides by 64. All right, so I get that my height is 16.875, and that's 16.875, and then my unit is feet. All right. So that's a very typical, like, working backwards example. Okay. All right. So give me just a second. Let me clear my screen off, and then we are going to talk about cones. All right, folks. So here we are on our couple examples here for cones. Okay, so you can see the formula right here is 1/3. So there's that 1/3 again, pi r squared, and then h, the height of the cone. Okay, so almost exactly the same as the volume formula for a regular pyramid. Because remember, pi r squared is the area of the base shape, right? Because that's how you find the area of a circle, right? So basically, we just replaced the capital B with pi r squared, because for a cone, we know that capital B is going to be pi r squared, because the base is always going to be a circle, okay? And again, just like in the previous examples here, we're dealing with the actual vertical height of the prism, not of the prism, sorry, it's a cone here, pyramid cone, right? We're dealing with the actual vertical height rather than looking at the slant height, which is what we did when we were doing surface area, okay? So just like in all of these others that I've done for you, I'm going to do a forwards and a backwards example, okay? So here's my forwards example where 12 is the height of the cone and 4.5 is the radius of the cone, okay? So I'm going to go ahead and plug that information into my formula. So my formula is the volume equals 1/3 pi r squared h, right? And I'm going to plug in the information that I know. So volume equals 1/3 pi, and then my radius was 4.5, so 4.5 squared times my height, which is 12. Okay, so I'm going to go ahead in my calculator. Now, since technically all of this is like being multiplied and divided, you can do it in a different order than I did, and you should get the same answer as long as you're not doing any, like if you're not multiplying when you should be dividing or things like that, right? As long as you're following your order of operations, you're fine. So 4.5, I'm going to deal with the exponent first. So 4.5 squared is 20.25. Okay, so at this point, I could multiply all of these together and then divide by 3. I could do 12 divided by 3 and then multiply, right? It doesn't really matter as long as you include each component. Okay, so solely because it's going to because the numbers are really close together, I'm going to do 20.25 times 12, figure out what that is first. So I have 1/3 pi, and then 243 is that product, 20.25 times 12. So then once I get here, I'm going to do 243 divided by 3, okay, because that's what this 1/3 does. So I end up with volume equals 81 pi. And then I need to multiply the pi through, and I'm going to do that directly in my calculator. So in my calculator, I did 81 times, I hit my pi button, and then I clicked equals, and I got 254.47 when I round. And then the very last thing I need is my units, which would be feet, because it's feet in the problem, and it's feet cubed. Okay? So that's a very typical, like, forwards example, all right? So let's do one more here. Let's do a backwards example. So here, they told me that the height of the cone is 8. I don't know what the radius is, but I do know that the volume is 135. So again, I'm still using the exact same formula. Volume equals 1/3 pi r squared h. Okay, so let's plug in the information that we know. Volume is 135, so instead of V, I'm going to put 135 equals 1/3 pi. I don't know what the radius is, so you can either leave it as r, or they called it x here, so I'm just going to go ahead and put an x there. So x squared, and then I have my height is 8, okay? Very similar to the last time we did a backwards example in this video. I'm going to multiply both sides by 3 first, just because that's going to cancel out this fraction at the front so that I don't have to deal with it anymore. Okay, remember, when you're multiplying by 3, what that's actually doing on the right-hand side of your equation is getting rid of this fraction. So all that's going to remain is this part, right? Then what you actually multiply by 3 in your calculator is whatever's on the other side of the equal sign. So 135 times 3 is 405. So I have 405 equals pi times x squared times 8. Okay, so what I'm going to do is I'm going to do this in one step here, but in your calculator you will have to do it in, you will likely have to do it in 2 steps. Okay, so I'm dividing both sides by 8 pi. The reason I'm doing that, okay, is because it's going to cancel out this 8 right here, and it's also going to cancel out this pi right here. Okay, so in my calculator though, what I'm going to have to do, so I'm going to put a little asterisk right here. So in your calculator, you're going to have to do 405 divided by 8 and figure out what that is. So I got 50.625, and then do 50.625 divided by pi. So you got to do that in 2 steps in your calculator, okay? Because your calculator doesn't really know, okay? So when I do 405 divided by 8 and then divided by pi, I got 16.11. So that equals x squared, because it's the only thing I have left. And then I'm going to take the square root of both sides. Okay, so when I do, I got 4.01 for x, and then my unit there would be meters. Okay, if you divided like at this step right here, if you divided by 3.14, instead of pi, you would end up with a slightly different answer. But again, when you're doing problems, especially for my class, it's more important that the process is correct, not necessarily like when you rounded in the problem, okay? So you may have not gotten exactly 4.01 if you did your dividing or rounding a little differently than me. But my advice is to, whenever you have the chance, use the pi symbol in your calculator rather than using the rounded version, which is 3.14, because you're just going to get a more accurate answer that way. All right, so this would be my final answer right here, that the radius is 4.01 meters. All right, y'all, so that is it for this video on pyramid and cone volume, and I will see you in the next one, whichever the next video is that you end up watching. All right, so I'll see you in the next one. Bye, everybody.